The Arduino software has already been uploaded. First thing I'm going to do is to set the voltage reference for the Arduino. This is in fact its supply voltage. On my computer the USB supply is only 4.75 volts. Set the COM port to the Arduinos. The baud rate 115200, jump weight 0, timeout never. If you've got this option, you set the data number to 1000. You can now capture the port. First thing I'm going to do is update the Arduino with the reference voltage, which it will use for calculating trig levels. I'll set a trig level. By default it will be on a rising edge, positive triggering in other words. I can type in test and then send it, or I have a button to do so. Test sets up a pulse width modulated wave on port 3. I've already connected port 3 to the input port 1. Now I'm going to do a single run. Note that it's triggered on a rising edge. I can estimate the frequency that it's showing around about 480 Hz. I'm going to do a repeated run. By using the Arduino's down arrow, I get negative triggering. The up button gives you positive triggering. The right button alters the timescale, effectively delaying between readings. The left button is the reverse. I can freeze the graph. Again, it'll give you an estimate of the frequency when you do so. If I press select on the Arduino, it stops the continuous run. Now it's no longer in a continuous run situation. Select gives you a one-off run from the Arduino side. I can save that graph. It actually saves it as scope.jpg to the Arduino oscilloscope directory. I can copy the graph to the clipboard. I can print the graph, and in fact it's the green area that gets printed. I can save the data. Data is saved as scopedata.txt to the oscilloscope directory. To end the capture at any point, I simply press stop capture.